Welcome to homework.
The magnitudes of the force tensions. So we can say that mass sub 1 is going to represent the 3.2 kilogram mass, and we can say mass sub 2 will represent the 1.2 kilogram mass. We can draw the free body diagram for the pulley. Going straight up would be force C, and to the left side, force tension, and to the right side, force tension. For mass sub 1, going up is, of course, force tension. Going down is sub 1 G, force of gravity. And then for the second mass, going up is, again, force tension. And going down is m sub 2 G, so the weight of the second mass. Let's apply the sum of forces for each of these diagrams. We can say force tension minus m sub 1 G will equal m sub 1 A1, and we know force tension minus m sub 2 G will equal m sub 2 A sub 2. We also know that A sub 1 will equal negative A sub 2 because one block is going up, one block is going down, and we're going to choose upwards to be positive. So we know that mass sub 1 would be going up, and mass sub 2 would, of course, be going down. We are going to relate this and say that the force of tension minus m sub 1 G is equaling negative m sub 1 A sub 2. We can say A sub 2 is then equal to m sub 1 G minus force of tension divided by m sub 1. At this point, we can say force tension minus m sub 2 G. This would equal, again, m sub 2 A sub 2, and we have an expression. So we have that force tension minus m sub 2 G will equal m sub 2 divided by m sub 1 multiplied by m sub 1 G minus force tension. And so now we can say the force tension will be equal to 2 m sub 1 m sub 2 G divided by the sum of the masses. And at this point, we can apply the sum of forces for the pulley. So we can say force sub C minus 2 times force tension will equal 0 because we have translational equilibrium. Therefore, force sub C will equal 2 times force tension, which will equal 4 m sub 1 m sub 2 times G divided by the total mass. We can then solve. So force sub C is going to be equal to 4 times 3.2 kilograms multiplied by 1.2 kilograms multiplied by 9.8 meters per second squared. This will all be divided by 4.4 kilograms, and this is equaling 34.2 newtons. So this would be our final answer. That is the end of the solution. Thank you for watching.